All right, for standard transformation form, let f of x be the parent function. Then standard transformation is given by g of x is equal to a times f of b times x minus c, and then close those parentheses, plus d. So this is an f of x notation, which might look a little strange. In Algebra 2, I doubt you saw it written like that. That is just because this can be used for any of the functions. So here I did a couple parent functions over to the side. So this one is the quadratic. So a times b times x minus c, all of that is squared plus d. And then the square root. So you can change the operation, but everything's still in the same place and does the same transformation. But this is just written in f of x notation. So the a, if you have a value all the way on the outside before your operation begins, if it controls two things. If it's negative, then you have a reflection across the x-axis. So if you have a negative a value, it's a reflection across the x-axis. And then you look at the value of a, and if a is between 0 and 1, then you have a compression, a vertical compression. Or if a is greater than 1, then you have a vertical stretch, which I guess I should have written the absolute value of a, because we're looking at the negative and then the numerical amount separate for the a. That's what the two bullet points are. And then the b value, so if you're inside the operation, so here inside the square root, or inside what's being squared, and there's a value there, the b value, that also controls two things. If it's negative, then you have a reflection over the y-axis. And then you also look at the value of b, separate from the negative. If b is between 0 and 1, then you have a horizontal compression. Or if b is greater than 1, then you have a horizontal stretch. And then the c value is what's with x inside parentheses. That is your left or right shift. Shift left, shift right. And the negative is part of the transformation form. So x minus c. So if it said like x minus 2, the 2 would be positive, so that would be a shift right. And if it was a negative 2, it would be x minus negative 2, so it would look like x plus 2. So the c is the one that's always kind of backwards of what you would normally think. So be careful with your left-right translations. And then if your plus or minus is on the very outside of the function, it's your d value, and it is a vertical shift, so you shift up or shift down, and it looks just like what would be expected. All right, and then we have, I'm just going to give you 3 examples. G of x equals negative 3 over 2 plus 2x and then minus 1. So the instructions for this would be to get the function into standard transformation form, name the parent function, and list the transformations. All right, so the first thing I want to do is get this into standard transformation form. And if I notice in the denominator, I have 2 plus 2x. That's not the normal order that we write things. Normally we write the x first, so I'm just going to swap the order in the denominator. I'm going to do arrow over, and I didn't do anything with the top. I have 2x plus 2 in the bottom, and then minus 1 on the outside. Okay, so now, if I look at standard transformation form, the x is always a singular positive x. It's 1x. So if there's anything in front of x, I want to factor it out. So I have 2x plus 2. So I want a singular 1x. So I want to factor a 2 out in the denominator. So over here, I didn't do anything in the top, but 2 and then parentheses x. Since I factor a 2 out, it's going to be x plus 1. And then the minus 1 on the outside. All right, so this is the rational function or the reciprocal parent function. I can, if I want to match that, that's 1 over x. Well, I have this negative 3/2. I can bring that outside. So I can make this negative 3/2 times 1 over x plus 1 minus 1. So I just pulled the negative 3/2 out front. I'll just put a little multiplication sign. So that is now in standard transformation form. So my parent function f of x equals 1 over x. That's the parent function. And then looking in standard transformation form, I see I have an a value. So when I list my transformations, it's a negative a, so that means I'm going to reflect over the x-axis. And then 3/2, the absolute value of the a is 3/2. That is greater than 1. Since it's greater than 1, this is a stretch. It's a vertical stretch. So then I look to see what else I have, and I see with the x, I have x plus 1. The form is x minus something, so this would be x minus negative 1. So that means it shifts, my c value is going to shift to the left. For the c value, I always draw an arrow on my function, because then whenever I look back to graph it or list my transformations or whatever I need to do with it for that problem, I see the arrow to the left. So I'm going to shift to the left 1 space, so left 1. And then at the end, I also have this minus 1. That is the d value. And it's minus, so it's going to shift down 1. Oh, this is a standard transformation form right here. My parent function and the transformations. And that is the same instructions that you're going to do for your assignment that I'm going to give you. Once we're done. Let's do another example, example 2. This one, m of x equals 6 plus the absolute value of 2 minus x over 2 minus 7, close the absolute value. All right, so we want to first get this into its standard transformation form. Well, I can see that my d value is out of place. There's something in front of the function, the 6. It's a positive 6 in the front. We want the positive 6 to be at the end. So I'm going to move that. And then I also see that I have 2 numbers inside the absolute value that I could put together. I have a 2 and I have a negative 7. Those are just like terms. I can put them together. So now I have the absolute value of negative x over 2 minus 5. And then close the absolute value and put a positive 6 on the outside. Okay, so we're close to standard transformation form, but again, we don't have a singular positive x. We have negative x over 2. So if we want that just to be a positive 1x, we need to bring the negative 1/2 outside. So I'm going to write that down here. So negative 1/2 x. If I want to cancel out a negative half, then I need to multiply by its reciprocal. That's how you cancel out a fraction, right? So negative 2 over 1 is what I need to multiply it by. If I multiply one of the terms by something, I have to multiply the other term also, or else I change everything, right? So then I'm going to take the negative 5. I also need to multiply that by the negative 2 over 1. This is just like scratch work to the side. That's why I was using the pencil. But here you go. Okay, so I brought down the negative x over 2 and I made it negative 1/2 x. I wanted to cancel out the negative 1/2 because I want a positive 1x. So to make this a 1, a positive 1, I needed to multiply by the reciprocal, which is negative 2 over 1. So the negatives cancel and the 2's cancel, and then I'm just left with x. If I multiply one of the terms, I have to multiply the other also. Since it was negative 2 over 1, that's the same as negative 2. So the negative 5 is times negative 2. Okay. So then I write that again. The absolute value, I'm bringing the negative 1/2 out front from the x. So then parentheses, x, and then I have negative 5 times negative 2 is positive 10. And close the absolute value plus 6. So what I did right here makes sense. Okay, because this is, okay, I'm just going to leave it since yes, then I'm going to leave it. All right, so here's my standard transformation form. This time I do not have an A because I'm starting with the absolute value bars. That's the operation. So then inside of that, I do have a B value, the negative 1/2, because it's what's in front of the x. And then I also have a C, since it's x plus 10, that's x minus negative 10. So that's shifting to the left 10 spaces. And I have a positive 6 on the outside, so it's going to go up 6. So my parent function here is absolute value. So f of x equals the absolute value of x. That's the parent function. And then list the transformations. So the b value is negative 1/2. Since it's negative and it's inside the operation, it's going to be a reflection across the y-axis. And then the value, the numerical value that goes with the b, the 1/2, that tells me it has a horizontal compression by half. And then my C value is the x plus 10, so it's left 10 spaces. And on the outside, I have a plus 6, so that's a shift up 6. It doesn't matter to me if you write the word shift. Shift left 10, shift up 6. As long as you get the left and the up and the number. Okay, I have one more example. Yes.
I don't know how you got to the standard point.
Here?
Yeah.
All right, so I have negative x over 2. So if I want a single x by itself, whatever's in front of it needs to come out. I'm going to factor it out. So since it's negative half is what I'm bringing out, and I want it to cancel to become 1, I'm multiplying it by its reciprocal. Okay, so like when I did it up here with whole numbers, it was a lot easier. 2x, I factored out a 2, and it left x plus 1 inside. But now it's a fraction. So when up here, I divided everything by 2, right? Let's see. So up here, I divided it all by 2, and it brought the 2 out here. And then it left x plus 1. But down here, I would be dividing by negative half. When you divide by a fraction, instead of dividing, you multiply by its reciprocal. So instead of dividing by negative half, I multiplied by its reciprocal, negative 2. So I'm multiplying both terms by the reciprocal, negative 2. What I did was I brought the negative half outside. So then x was by itself, a single x, and positive 10 was the negative 5 times negative 2. We're going to have another example with that. So the third example also does that same thing. P of t, so this time the x is a t, it doesn't matter, it's just another variable, equals the square root 2 minus 3 over 2t plus 1. Also, I put a little tail on my square root radical to show that I'm done with the square root, and then this is outside. So I don't accidentally end up having the plus 1 as I'm halfway through a problem, have the plus 1 under the radical when it wasn't supposed to be there. So that's what this little tail is for. All right, so first I want the t to come first. So I'm going to make this the square root of negative 3/2 t plus 2. And plus 1 outside. All right, so I need this t to be a singular positive 1t. So that means I need the negative 3/2 to come outside. Okay. So I know I want this to be negative 3/2 on the outside so that I have a t by itself. That's what I'm trying to do. So I have negative 3/2 t. To make it into a 1, I'm canceling out the negative 3/2. So I'm multiplying it by the reciprocal, negative 2/3. Okay, so I have negative 3/2 t, and I'm multiplying it by negative 2/3 to cancel everything out. And if I do it to the t, I also have to do it to this plus 2. I need to multiply it by negative 2/3. So here the 2's cancel, the 3's cancel, the negatives cancel, and it's just t. And then plus, this is like 2 over 1, so 2 times negative 2 is negative 4. And 1 times 3 is 3, so negative 4/3. Oops, parentheses. Plus 1. Does that make sense? All right, so now I'm in standard transformation form. My parent function, f of t, is the square root function, square root t. And my transformations, they begin inside the radical, so that makes this a b. So I have a reflection across the y-axis. Reflect over y-axis, because it's negative. 3/2. 3/2 is greater than 1. So this is a horizontal stretch.
But are you multiplying it by the reciprocal, so wouldn't it be negative 2? Like in the next box.
Yeah. The reason we're multiplying it by the reciprocals is we're factored it out. So it's like saying divide the whole thing by negative 3/2. And then on the inside, so then we have t minus negative 4/3. So t, since it's minus, that means it's going to go to the right. So we're going to shift right 4/3. And then the last part is to shift up 1. Okay, so I have an assignment of 6 questions that I'm just going to put in OneNote for you to see, because they're not from the book.